will act, then resultant force, how to calculate. It has to be analyzed. You have to take into mathematics. The engineer is not something wearing good dress, looking handsome or very beautiful, then going to that one. It happens in movies, sir. Engineer means what? When your brain will be tortured like anything. You will not be let free by anybody. The company will torture you. There'll be absolute mental torture will be there. Your brain will be squeezed like anything. That's what engineer means. To become unhappy or going to become engineer. That's all. From the beginning, I'm sticking on to the same thing. Okay, let's get into this one. What is this? This is the surface. The curved surface is very important. First of all, okay, sir, like show me how the forces are acting. There's a primary question you can ask. Okay, let's do one thing. Let's draw the triangle. Okay, we have. I think semicircle is needed. I'll adjust the diagram. Give me some time. Yeah. Not semicircle. Yeah, fine. Okay, this is the semicircle. We should have a triangle. There's a triangle. Okay, I constructed the thing. Okay, let's show the forces that are acting. So everywhere liquid is present. There is everywhere liquid is present, and look at the nature of liquid. Substitution of water and soap film are. It flows on the surface of a soap solution is dropped over dotted region. Here is what soap solution is there. So how to get the soap solution? Just it's floating water in this region. You drop some. So what you can drop? You can just drop some detergent powder in this region. So it will mix. So yes, surface will change, and the rest all everything will be water. Rest all everything water. I'll not show it. Only this triangular lamina. I'll show this one. Okay, now at least. Okay, tell me the forces. The white color is now what like a water. Okay, fine. So now let's get into the where the force due to suffocation. So here the water will exert a force. And tell me how the soap solution will exert a force like this. Is it okay? This will be the radius r. Soap solution, here water, here water. There's a triangular shape. There's a sheet. Don't show vertical. It is lying on surface. The molecules which are present here will try to pull the sheet like this. The molecules which are present here will try to pull, and the molecules which are present here will try to pull here. Okay, there's no problem with this force, no? So what is the sufficiency? T1 is given. Sufficiency of water is T1. That of soap solution is, sufficiency of water is T1. That of soap solution is T2. Okay, there's no problem. Okay, then force due to water, we know how to find out. Force due to soap solution, how to find out. It is not something. So here we'll get into the diagram. We have to take the mathematics. Let me get this one. So this is the curved surface. Please, all of you, try to concentrate. It's a, rather than numerical, it's a theory. Like this is the nature of the force due to sufficiency. You should work out here. So everywhere will be acting. So let me take this small surface ds. So this will subtend an angle d theta. So here soap solution is present. So what it does, it will exert force according to that arrows. Violet color or dark blue color arrows is what I'm showing. Now the net force by the soap solution on the sheet, on this curved surface, in what direction it will be. That's what we are trying to learn. Fine. So here the force will be df. This is df. So if you further extend this line, so resultant force, how it should be? Vertically down. Resultant force should be vertically down. So therefore this should become equal to df dash, will write it. So the df equal to 2 df dash cos theta. What is df dash? Sufficiency into length, dl. I'm asking you to take some small length, elemental length. Then what is sufficiency force? Force due to sufficiency into that length. So sufficiency is how much here? Soap solution is how much? T2. T2 into dl cos theta. So 2 into T2 as it is. dl is what? Angle subtended by it. Radius is r. Arc length is what? R into angle subtended. This is force due to soap solution. Anybody limit? 0 to pi by 2. Zero to pi or 0 to pi by 2 I should take. 0 to pi by 2 I should take. So this will become 2tr. Sine integral of cos theta. Integral of cos theta will be sine theta, sine pi by 2. So this will be 1. So how much we are getting this? 2t into r, or this is better right like this. No, this will be very troublesome. Sir, earlier you said like we should calculate the length. Effective length is, so in the definition, force due to sufficiency. Sufficiency equal to force by delta L. No, what is delta L? Delta L is here effective length, not just length. So what is the actually the curved length? Pi r. But what is the effective length? Will be 2r. I'll give a few more examples. I shown there's a proof everywhere you're going to apply this one. Okay, let's get into the our problem. You just take most of the textbooks we have. No, see, textbooks, they just only give some small basic ideas. Huh? You can't revise with the textbook. Again, you should come to the teacher notes, because see, we give all the vast ideas. Huh? You are doing revision, you should do revision with the teacher notes. Huh? You open textbook. Do you have anything like a delta L information? Nothing. No, they just say length. But here it should be effective length. Okay, now let's get into one by one. Let me get into. So this is a sheet. No, what are the forces that are acting? So let me bring only the sheet. Okay, now tell me like a force due to this will be how much resultant force? How much it should be? Force due to shall we call this is F1, this F1, and the resultant force, this should be F2. What can be angle? It's a equilateral triangle, no? R and R. So what is the angle it will make? This one. What is the angle made by this? Anybody? Angle 30 degrees? It should be 30 or 60. 60 degree, right? Let's get into this one. What is F1? We'll calculate one by one. So what is F1? What is F1? F1 should be, I think I'll write nearby this one. It'll be easier. What should be the F1? F1 should be force suffocation due to water. It should be T1 into R. What is F2? F2 we calculate. T2 into 2R. Net force on the sheet should be equal to F2 minus 2F1 cos 60. It is floating means, see, like a here, F1 will be everywhere here, no? So this should be the F1. F1, what happened here? Water is present. So all the water molecules which are present will exert a force. Fine. Equilateral triangle. Are you not seeing equilateral triangle here? No, you should say R, R, R. This will be 30. This will be 30. So this should be perpendicular. So this should be 60. Fine. Okay, now let's get into the calculation part. What is F2? F2 will be T2 into 2 T2R. 2 F1 is how much? T1 into R. This is 1 by 2. So what we are getting? 2 T2 R minus T1 R. What is T1? T1 is 1.5 times of T2. T1 of water, no? Sufficient of water. And okay, fine, yeah. T1 is 1.5 times of T2. Which force will be greater? It's not that I think really we have to put effort. No, it's not something like a formula is there. I'll apply it. Huh? Okay, look at this one. What is the direction of this? Or if you are writing in terms of T1, okay, he's asking in terms of T1 minus T2.
Sir, F2 should actually be T2R, sir.
F2 is T2R only.
Yes, sir, because there you took radius as r, but radius of hemisphere is radius of semicircle is actually
Oh,
r
oh,
by
oh,
2,
oh,
sir.
oh, oh, this should be the r by 2. Huh?
Yes, sir.
Okay, okay, fine. So this is r by 2. I'll do one thing. I'll bring smaller so that it'll be easy for us to think. Some smaller. I'll make it. Replacement will be easy for us. Smaller is equal to now will be r by 2. Huh? Yeah,
Yes.
fine. F2 is how much now? T2 r by 2.
Sir, 2r, no, sir. So T2r. 2 small r, no, sir.
No, 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 no. Okay, 2 smaller is r, capital R, no?
Yes, sir.
Smaller will become r by 2. Okay, two smaller will be r. Only r will come. Okay, ma, yeah. This will be T2R. What else? Okay. Yeah, this 2 will not be there, no? So this will be, no? Which will be greater? T1 will be greater. Okay, this one. I think I should take the result enter. F2 minus, will arrange like this. Huh? Okay, no, this will be the net force. So how it will be directed? I just made some adjustment all, just make notice here. Okay, fine, no. Huh? So T1 will be greater than T2. So therefore, shall we pick up this option along positive y-axis? Now you see this. I follow. Okay, fine. This is everything answered. Okay, this is very important. If you get a curved one, the force you should calculate like this. Very, 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 very important. No, frame expensive force. Okay, option A and B I'll pick up. Now, what about the resultant force on the wire frame is 0. Okay, not possible. No. What about along x-axis? X-axis net force should be 0. Net force on frame along x-axis must be 0. So still, just make observation. I'll give one more idea so that it'll become very firm for you.